Hello everyone. Myself Gautam HD. I'm studying in Sri Venkateshwara College of Engineering. I'm studying in second semester. My SN is 1VE 22 CS 051. The subject is maths. The topic is bisector method, language, inverse interpolation. Bisector method language, inverse interpolation. Understanding numerical methods and roots is essential for anyone dealing with scientific or technical application. In this presentation, we are gonna explore about this topic and know little about this topic. Bisection method. What is bisection method? How does it work? Examples. These are the questions we have in mind before we are moving on to the bisection method. Bisection method is a numerical technique used for finding roots of nonlinear equation. It involves dividing the interval containing the root in half and selecting the interval in which the root lies. How does it work? This method requires choosing an upper and lower bound, repeatedly bisecting the interval in which the sign changes until the desired level of accuracy is achieved. The example, f of x is equals to x cube minus 2x square plus 3x minus 7 is equals to 0. Find the root between x and 1. Here, the bisection method, we are finding the nonlinear equations. It involves a dividing the interval containing the roots in half and selecting the intervals in which the root lies. We are taking a two bounds, upper bound and lower bound, and we are bisecting the interval until the sign changes until the desired output or required output comes. We are going to repeat this method. Next, language of inverse interpolation. First, what is interpolation? Interpolation is a technique used to estimate data values between known data points. It is a point when the exact function of the data is unknown but the key point is present. Yes, here basically we know the two known data points, then we need to find out the exact unknown data point, which we are going to find out by using interpolation method. Here there is a formula, linear interpolation formula. Y is equals to y1 plus x minus x1 into y2 minus y1 whole divided by x square minus x1, where x1 and y1 are the first coordinates, x2 and y2 are the second coordinates, x is the point to perform the interpolation. Then, what is inverse interpolation? Reverse interpolation is a reverse interpolation in which you use to input value of the function corresponding to output value. Here, we are finding the input value with respect to output value. Then here we have a graph. There is a two lines. First is the base distance varying interpolation method, which is represented by a blue line, where it gradually rises from 3, 4, 2, and it goes on up to in a linear manner to 20 and goes on. Second one is the orange one. It is adaptive inverse distance varying, which rises gradually and which grows exponentially over, and it continues its graph. Then, how does this relate to polynomial regression? Inverse interpolation is a crucial step in the polynomial regression process, as it is used to calculate the coefficients of the polynomial from the data points that do not fall exactly on the curve. Here basically we are finding the coefficient of the polynomial which exactly do not fall on the curve but which near to the curve. By using this curve method, we are going to find out the coefficient of the polynomial. In the picture which is right above this topic, we can see that there are three lines which exponentially rises. There are green line, orange one, and the purple one, where it ranges to different. First 10th it rises and it ends at 0.10, and the orange one rises, it ends between, it starts at the approximately 0.18, and it exponentially grows downwards the curve. And the last one is purple one, which is approximately at near 0.30, and from there it falls down. What is inverse interpolation and why do we use it? Yeah, this is a major question. We know the method, but we don't know where to use it. So let's have answer to this question. Applications. First definition. Interpolation is a process of finding the value of the argument, the value of x, which is the value of the argument, that corresponds to the given value of the function, which is a y, which is the value of the function. We are going to find out the value of argument, which is x, and that corresponds with the given value y. Here we know the y value, then with the help of y value we are finding the x value. Next, application. Inverse interpolation is used in a variety of applications such as metrology, computer graphics, financial modeling, scientific data analysis. Interesting, right? It is used in metrology, where meteoroids are moving in the solar system, which is outside the belt. And computer graphics we use for various graphics such as animations, movies, and video editing. We have where graphics are commonly used. Then financial modeling. With the help of all the graphs, we can predict or we can use in the financial modeling how the financial system works, or how it's gonna boom up or boom down, when it's gonna fall or when it's gonna rise. We can just get the data, or we can just predict the data with the basic use of this maths and its applications. And the scientific data analysis. Yeah, data analysis of these days plays an important role. It lets us to know where we stand in this current scenario, in this huge data is all over going to the world. So we can analyze the data which we have, and we can come up with the better output or the better idea to tackle the current situation with the data analysis. Third, advantages. It's a powerful tool for solving equations that cannot be solved analytically, and it allows the accurate estimation of the function where data is a sparse or incomplete. Yes, it's really a key point. It's a major point where we can solve the equation which cannot be solved analytically, and it lets us to know the accurate estimation of the function. It is truly fascinating, right? Yeah. Methods and techniques for inverse interpolation. There are three methods: Newton-Raphson method, secant method, linear interpolation. Yes. Newton-Raphson method. A root finding algorithm that is efficient for finding the roots of function using iterative approximation. It requires the function to be differentiable. It's basically a root finding algorithm which is efficient and also helps us in finding the roots of a function using the iterative approximation. It requires the function to be differentiable. By this way, we are going to find the answer by using Newton-Raphson method. And the second method is secant method. It's a numerical method for approximating roots of function by using the succession of the roots of secant lines instead of computing the tangent line method in a Newton method. Here we are going to find out the approximation of the roots of a function by using the secant lines, not the regular or the common default computing the tangent in a line. Linear interpolation. Yes, we also read the formula where y is equals to y1 plus x minus x1 into y1 minus y2 whole divided by x. That is the formula we read in the earlier. So it is the same formula. Linear interpolation is simple and intuitive method that involves the drawing a straight line between the two known points using the line to estimate the value of the function. Here, it's a simple method. We use drawing the straight line between the 2 points to estimate the value of the function of any points which lies in between the points, where we can know the unknown value by knowing the two known values of the straight line. By estimating this method, we can find it. Examples of inverse interpolation: first one, trigonometric function, then financial modeling and metrology. The arcs in the function is the inverse of the sine function. It returns to the angle for the sine function is equals to given value. Yes, there is a value of a sine curve where it rises from 0 to 90 degree and reaches 180 degree, and it again goes back to minus 90 degree and reaches to 180 degree, then again to 90 degree as this sine curve goes on. Next, financial modeling. Stock analytics often use inverse interpolation to find the implied volatility of an option from marketing prices. Yes, we can analyze the stock 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 growth, or predict the graph, how it is gonna rise and fall by using the inverse interpolation method to find the implied volatility of an option from market prices. It's truly fascinating, and it is very helpful in the predicting the market, which is totally unpredictable. It it puts us the way ahead of other than those who doesn't use this method in exceeding in the financial modeling. Then meteorology, it's a weather forecast. Use inverse interpolation to determine forecast position of a low pressure system from the measurement taken in the surrounding locations. Yes, we can forecast the weather by using this inverse interpolation to determine the forecast position of a low pressure by measurement taken in the surrounding locations. Conclusion and summary of key points. Root finding is a fundamental problem. It is essential for many scientific and technical applications. Then, bisection method is a powerful numerical technique for finding roots of nonlinear. Then, inverse interpolation is a process of finding the value of the argument that corresponds to the given value of the function, and it is used in many applications where data is sparse or incomplete. First, we can use in scientific and technical application. Then, in bisection method, we can find the roots of nonlinear equation by this method. Then, inverse interpolation, we can find the value of the argument corresponding to the value. Yes, we came across this method earlier, where we can know the y value. We don't know the x value, which is the value of the argument. By using the value of the function which is given, we are going to find out the value of the argument which is unknown, x. And it is used in the application where data is incomplete or space. We don't have the complete picture, but we have a parts of the picture. By using this inverse interpolation, we are going to see the picture bigger by using this maths and its application. Thank you. Have a nice day. Maths makes more sense when it is applied rather than studied. Thank you. Have a nice day.